Hello, hello, hello. Welcome to another stream. Let's get started on some awesome stuff for the terrain again. So I brainstormed a little bit yesterday on how to tackle the terrain stuff, and I think I have an idea. Let's see how good it turns out to be. It's definitely something worth trying. So the idea would be that, yes, exactly, we built this volume sparse oak tree, which we renamed to maybe volume word chunk oak tree. I'm not sure, maybe that. I'm not sure. And that is basically that, and it's not that. Is it? No. Because what we want in reality is this. Word chunk size. That is basically that. Divided by 16. Word oak tree max depth 4. And then we have const Onyx S32 word oak tree. Or not that actually. Then we can do one shifted by 4 whereby word oak tree max depth, which should be 16, right? Yeah. And that should be that, and then this is our chunk tree size. And then is where that one plus 2 times that. Hello. Hey, Roy. How are you? Having a great weekend so far. And we basically seal that, although, yeah, we seal that, right? And then we cast that to U32, S32. So that should be our root size, which I'm not sure if we need here per se. Let's actually save that. For plane. Oh, okay. Well, I saw that there's a new one. I'm not sure if I want to. I'm not sure if I want to see that. I didn't even see the other latest ones. Cool. Yep. Probably. I stream usually until 5 or 6 p.m. on the weekends. So let's see. There's a good chance that I'm still here. So let's get rid of all of that. Yeah, enjoy the movie. Bye bye. And hopefully see you later. Yeah, so we do that. And then this is basically our... Is it 16 times 8? No. Is it 8 by the power of 4? Is that it? Oh, very cool. Yes. Which is Octree has 8 children, right? Shifted by word Octree depth. Okay, that's not it. Why? Unfortunate. It's... How would you calculate that? I mean, it's basically 8 by 8 by 8 by 8, right? Yeah. Which is 2 by the... 2 shifted by 10 is 1024, right? No. So it's that? By 11. Yeah, that doesn't really make too much sense. So I guess we just stick with STD POW. And then size of word sparse Octree node. That would be this one, which is our sparse octree for the word, which actually is not so sparse anymore. Let's call it that actually. We might rename that. Or chunks octree node. And we do that, and we create it. Then we have as well the active chunks, which we still use. Which as well will be basically that. Or do I need that? Do I need that is the question. I don't think I actually... Don't think I actually need that. Let's get rid of that. We might not need that. And then we have each chunk. And each chunk will have its volume, well, its mesh stuff. The draw command buffer. Basically internally as well. Basically voxel octree. Like a volume octree, let's call it that. Yeah, we will probably have the coordinate. Don't need a size though, right? Because that will be basically here. And then chunk size is our root size, again divided by that depth. And what that does is we basically see how big our root is, then we divide it and find our chunk size, which would be, for example, 4069. Then we grow the root by 2 so that we have some buffer for streaming. And then we divide again the root size with the adjusted size by our max depth. So we are a little bit bigger than 4069, right? In this case, we probably are 4,500. So 4,500 or something like that. Big per chunk. That is done for chunks tree. And then we build this and we build here the voxer. One. No, not that one. Do I not have that anymore? Oh, here. Hey ho. Good evening for you. For me, it's not evening yet, right? But welcome, welcome. Chunk. Volume octree. We might actually fill out some additional data here. So let's actually not do that. We just fill it like that. And every time we build one, we actually fill some stuff here. Do I have a vector 3 to string for formatting? Maybe I don't, right? I mean, I can do X. Like that. Well, the GPU structure is just how the buffers are basically, what kind of buffers data we send, more or less. It's what I meant with that. So what we will do, I can paint it maybe. Is paint the best? I don't know. So we will have two structs, basically a word octree. Maybe smaller. And then we have chunk, or like, yeah, volume chunk octree. So basically this one, would be max 4 levels deep. Spans the entire world plus 2 margin. What I mean with that is that we have the entire world here. Or that's already with the margin. And then we would have here our actual world size. And then this would be basically 2 chunks margin in between here. What that allows us to do is basically have some buffer for streaming, right? And then you can imagine that it's fully subdivided like that in every direction. So we have like in total like 4069 nodes. Which might contain data or not, but they are super lightweight. Because they are just storing basically if they exist or not. So that would be this struct here. Where is it? This one. Where basically we have one offset into the octree itself if we are a child. And if we are a leaf, we have an offset into the chunk tree. Basically. So we have as well 4600 of those, basically. Because that like has to match, right? Basically those two correlate. And then internally here, that one basically goes levels up to min size based on camera distance. Which basically means the first, like if the player is somewhere in the world here, we have like higher subdivision in those chunk octrees around the player. But down here we have like, let's say 8 meters or like 10 meters resolution. So each, so it will be very, like if we have world size of 64 kilometers, like one of those chunks in the world octree would be 4096 meters. And to get to like 8 meters resolution, for example, that's just 512 nodes, which I think is 3 levels or something like that. 8 times 8 times 8, yeah. So the chunks outside here would be almost not subdivided at all, whereas here, if we want to get lower resolution, right, we would subdivide it more. That would be the current plan. And that will give us automatic LOD as well. If that makes sense. It's a bit hard to draw, but that would be basically. I have a question. How prevalent is volumetric terrain? Not that prevalent, I would say. There are a couple of games that use it. There's a little bit of research going on as well at bigger companies with volumetric terrain. Because the hardware now is more capable than previously. It makes definitely the whole... Yeah, it definitely is a little bit more advanced. But it's not something super new. There's very old games that already used volumetric terrain to some extent. But yeah, it's definitely not trivial, let's put it that way. But it's something that I really enjoy investigating. So that's the whole reason behind everything here. Actually, can I make that not smaller now that I know that? No, I mean, this needs to be a U16, I would say. That can be a U16. Then we have like 6, which is kinda useless, right? So at that point we can probably just do U32. And then this is 16 and this is 16. Does that make sense? So that 32... I think we have a little bit of buffer then, right? Oh yeah, we have 48 as buffer, so we can do here 24, 24. No? What kind of games would benefit from this? Not necessarily, or it doesn't have to do anything with open world. I mean, the stuff that I'm currently building would be with an open world, right? Because I try to scale it. But with a small volumetric terrain, you can do that as well. The biggest benefits, like gameplay wise, is that you can do mechanics like digging and, I mean, in some sort like building, but like more in like you shape the terrain, right? So for example, you can think of it like Minecraft, right? Minecraft is a voxel game. Roblox is a voxel game. But they have like the blocky look. And I'm trying to extract a smooth surface, but that's just like one detail. Like those kind of games are volumetric. It's just that it's called voxel in like the broader term. So, and as soon as you want to have like some properties assigned to like objects within your world, right? In Minecraft you can dig and you can find ores, and with that you kind of need some volumetric representation so that when you dig and encounter an ore and you harvest that ore from the ground, it basically gets into your inventory and stuff like that. So you have in those kind of games always some sort of representation of volumetric data. Yeah, exactly. Exactly. Worms would be like one game which, I mean, it's 2D, but it's the same principle. It's like volumetric-ish data. It's just that it's in 2D. But Worms too, like Armageddon and stuff like that, they had like destruction, right? And usually you, even though it's like 2D, it kind of follows the same principle, right? I mean, granted the 2D version is a little bit simpler, but yeah, you can destroy like the terrain, right? And dig holes and bombs and everything. And with 3D, like volumetric terrain, you can do overhangs, so you can do stuff like that. I mean, this is again 2D, so not sure if Worms really uses volumetric data, because in 2D it's a little bit simpler, right? But usually in modern games for 3D worlds you use like a height map, right? And the downside of height maps is that you can only have like one height value per pixel because it's a texture, right? So you can never do like overhangs of cliffs and stuff like that. So your terrain is always kind of like you would draw it on a paper, right? 2D. And with the volumetric stuff, you can do like overhangs and everything like that. And caves and stuff like that. In modern games, caves are usually like a cutout of the height map, and then you place a model in there, which is a handcrafted model by an artist. And like cliffs and stuff like that are most of the time as well props that are just placed. Exactly, static mesh caves and static mesh cliffs and static mesh overhangs and stuff like that. You always fake it a little bit in games. And with this you can do like real cliffs and real overhangs and stuff like that. Nope, they did not. They did not answer. It's very sad that they didn't answer yet. But I don't know when they will answer. Well, let's see. Let's see if they ever answer. Alright, so what we would probably want to do... no worries. I mean, that's why I'm streaming, to explain stuff, right? Maybe we do it like that. Let's do it like that. Okay, we put that here. That one we get away with. Okay, so we have that. And then let's build the... That was last time an issue, right? How do I do that with the shaders? Because the shader would be nice if we already have it loaded. Probably is not loaded. And do I want to block here to load the shader is the question. But maybe we do. Anyways, we need a new shader anyways. So we go... Oh god. Into the dependencies in... That's really the pain of all of this setup for the project. I think most likely I prefer the submodule in the end. Because then the engine code is a little bit more accessible. Data. Shaders, compute. Probably volume. And we create a new one. I got that from my fiance as a birthday present. Not sure if we will ever sell it, probably not. I mean, maybe. I don't know. But maybe an engine would be helpful first before selling merch for an engine that is not functional to do games with. Maybe one step at a time. Build volume word, build word chunk. Oak tree shader. And then we have this. We basically copy that in because it's easier that way. We can keep that for now. And that is the fun part. So what I will do is we basically make that 6411. And then we have to replicate our word. What is it? Word chunk octree, or what did I call it? This one. Like that. And this is basically a u, well, a u and u, and we don't support that, so we don't do it. And then this is probably a uint as well. Then we have a write only buffer and a read only buffer. But we will do it the other way around. And the read only buffer is basically create queue, create requests queue, request. Is that how you write request? It looks so wrong. Okay, it's correct. So we build it in 2 steps, right? Or like in n steps, but yeah. Create requests, and then this is out, or like how do we do that? So one queue is the thing how I want to build that shader is in steps. So we know that when in C++ we know how many levels we need at maximum. Max depth of octree, let's say, is 4, right? So what we then do is we build 2 queues, create 2 queues, which are just SSBO buffers, which basically define, like, one is always a read and one is always a write queue. And we basically init it with like one create request for the root of the octree. I mean, we could probably already initialize the whole chunk tree with a root node. Maybe that makes actually more sense, because then we can skip the first part. And then we dispatch basically the root node with the out create requests queue, which would be this. It's a little bit convoluted, but it will work. And it basically is the way how you build nicely an octree dynamically. And then this one in the compute shader, it will say, okay, I need 8 children or not. And it does that by pushing 8 create requests into the out request queue. And it will as well push an indirect draw or an indirect dispatch, right? Which we need here as well, the buffer. And then in C++, we just queue dispatch level 1 and dispatch level 2 and dispatch level 3, right? And then we are 4 levels deep. And this always, and then basically before we dispatch here, we swap read write queue. And we, again, for each child, we basically do that. And that way we scale like the octree up in the GPU. And each child can decide if it needs to subdivide or not, right? Either it pushes something into the dispatch or not. And then we swap again. And we do that all the time, right? Because we get like 2 queues. One is the read access, one is the write access. We read and push into the out, which is like the creation request for the next tree level. Then we swap it. So the write from before becomes the read, and we write into the read from before because we don't need it anymore. And that way we basically build up the tree. And if at some, like if this dispatch does not write anything, we just have like, yeah, this dispatch, but it doesn't do anything because it doesn't get indirect dispatch. So it basically results in nothing. So at worst case, we already know beforehand that we are at least that many levels deep, and we always know how many levels we want to build. So on the C++ side, we just say dispatch all the levels. And the GPU will handle the rest. That is the idea. The only question is for the create request, I'm not quite sure what I need to push. Because I probably need to push some data here. And not just the level I know. But I always need to know my position, right? Which probably I could encapsulate in like 1 uint 32. With some Morton code information. But okay, let's deal with that later. Let's first try to figure out. Well, actually, I need that already, kinda. Let's put in a uint here. create index or like chunk or node index. Let's do node index. And this is as well node index. And as well a uint. Okay. And now we always get not that, we don't care about that. We get the create queue. We get the out. So those two. And now we probably get the u in depth, which basically tells us which depth we are, so that we get the cell size. And I think that's it. Don't think we need more than that. Well, we need vec. Well, actually, u and word, well, root size. Root extends. Right. Or do we just push the extends? Maybe we just push the extends. That should be good enough, right? Do I need an offset? No, I don't think so. We can always have it centered around the player, so it's 0, 0 centered. And then we just need the dispatch thing. So basically here we do buffer reference, indirect dispatch, buffer. Then I have no idea how that looks actually. It's just that or what? Okay. Well, that is simple. So basically it's just a dispatch X. Dispatch Y, dispatch Z or what? That's it. Which in our case it always is. Indirect dispatch. Which in our case, those are always a 1, right? So indirect dispatch while you indirect dispatch. Let's actually so those are always like that. And then the X will be defined by let's actually have to define here. It will actually help us a little bit. All right, so GR global invocation ID X. I think that's enough, right? Because I don't think we have anything else. That should be enough. So we do that, and then we want to get basically our position. Oh no. Well, we get our U and node index. Well, that's actually a Morton index, right? That's the idea behind that. So basically we would do U constants create queue at node indices global ID. Do I need to check something? Probably I need some bound that I'm not reading outside here, because if I do 65 entries, I will launch 64 that are 63 that are useless. So that will be a little bit interesting. Probably actually build that up here. Like basically build like a counter here. Something like that. Probably it has to be before though. Something like that. So basically if our global ID is greater than then we return. And then here we have our Morton index. Oh, we need this buffer as well. Which is a fascinating one, because that will be a U int 64T, where we need the extension for that, which I think we have somewhere. No. Okay, maybe we didn't add that yet. Work on UN64 extension. How is it called? Of course it was. Yeah, but I need... No, that's not it. There is an extension for that you need to define in the shader. UN64 GLSR. Is it that? God damn it. The door slammed. I had it somewhere and then I lost it, I guess. It's not that one, I think. I mean, maybe it is. Say UN, or is that, does that contain UNs as well? Ah, it does maybe contain. I mean, we can try. Word nodes. Word chunks octree. And then let's actually yeah, and then we basically say u constants, or actually UN64 chunk node, or like just word octree node. Which is our u constants. Word octree nodes at, god damn it, at node Martin index. Yeah. Actually, let's do a helper here already. Which is basically this. Get node. Like get octree node. And Martin index. While out. Is node and 0. Can I just do that? But or does GLSR support 0x or stuff like that, like hex? I mean, we can do as well one shifted. But I don't think it supports hex, right? Probably. Oh, okay. Okay, no, it does support. But I'm anyway stupid. What is 8? That is probably 1, right? Or nothing. Yeah. So F 15. Oh, I want it like that. That one shifted by 8. And then we do that. That is the valid mask. That is the child mask. Do I need that in this case? Actually, in this case. In this case, I can actually initialize it to 0 because we are creating a new node anyways. So probably I don't even need to do that. But I need the write then later. So I actually don't need to do that. I create a new node, right? Okay. Okay, that was not valid, okay. Valid mask 0, and then we do node. What else do we have? Children offset. And node voxel offset. Perfect. Okay. Nice. Oh, we need a... Or do we need one? Oh no, actually we don't. Children offset. Do I need... So I write myself always into that. Hello, Captain Chica. I think I need a counter. That one can be... nodes. I think I need that, right? But I only need that during creation. I don't need that any time after that. Yeah, I think that's fine like that. Okay, then let's do it like that again and move that down again. So that they're together. Does it even fit? So that's... Yeah, it should fit, right? So this is 16, 16. Yeah, that's definitely fitting. Let's remove that. We don't need that right now. So we do that. We need this, and then from this we need to get our position, which basically is similar to that. So we probably add like a include. Shaders includes. Not sure where. Let's just add it empty here. And basically we do a U and 2 Morton code. And we get a vec3 position. I mean, vec3 or ivec3. Probably ivec3 makes the most sense. And then we basically do that, right? It's always the same. Funny. Does that even work? Wait, that's probably not how it should be, right? Let me double check, how is that? Oh, we get a U in 30, like we get a U end like that. And we do that, and then we basically parse that out. And that is the encoding, and then the decoding is... we get a more than... yeah, exactly. Yeah, I call you crazy for doing that. That is insane. That is more than insane. Is it the same? So we have this. No, that's not exactly the same. Hold on. God damn it. 4, 3, 2, 1, yeah. Or 3, 2, 1, 0. Perfect. Let's do that. This is a U end again. Chord. I hope that works. Oh. I hope that works. So basically, we need more than that then. We need like this, right? Three. Decode Morton. That is an IVX3 coordinate. And then this is 2 from Morton code, is that right? Probably. Let me know what is an issue. What is it? You and Morton. To Morton code. Coordinate X. Coordinate Z. It doesn't say that Ubisoft can't use it. Oh no. You would need to do a licenses. I thought that the source code is covered with Polyform. Isn't it not? So I am using, which one I'm using again? This one. I mean, maybe. Maybe, yeah. I will look at that. Definitely thank you for that. But then again, I think as long as there is no license for it, it's anyways not permitted to use it, right? If I don't give you explicit rights to use the source code, it's basically not allowed. But yeah, better to be explicit. So I vec3 coordinate is basically we unpack that. So we include here Morton.h. You're in Europe, in France, there are French things going on. Okay, whatever that means. Decode Morton. So we do that, and now we get our vec3 position. That is true. But I cannot stop that anyways, regardless of what I do. Or, I mean, yeah, not pushing it to Git would be one option. Like not pushing it on GitHub. But coordinate time xyz times extends. That should do it, or? Well, not really, or does it? Does that do it? I do have a smart box. You can see it. So the fan is on top of it. That's a small server now. I had that before. You spent the €2, but thank you. And that is currently a data storage server, but it will eventually be. So the plan is that I'm use it for GitHub actions to build, and probably it's where the GitHub repository might move, but the documentation for sure will move. So the documentation will be on this server. You game developers never understand. Yeah, I don't probably understand what you. If it was a joke, I didn't understand it. Decode. Do we use that somewhere? No, right? Is that not it? Git is more like a geo backup to me. Yeah, I mean, probably something along those lines. Okay, so we actually have that here, which we need as well. That's like the traverse down, which maybe we don't actually need that because I'm using Morton, so it's fine. Split policy. Damn it. Split policy. Where is that card? Ah, here. Exactly. Root node size depth. And then I want this. Oh, that is interesting how I'm doing that. Wondering if there's a better approach to that. There should be a better approach. That sounds too stupid to do it like that. that really? I mean, it would work. Although, how does... Wait, what? Why do we have 3 here? Okay, never mind, that's not how I would want to work. How I would want it to work, so get a sentence out here. Well, future me. Regarding that, we can probably... Oh no, it's actually not future me, it's me right now. I need to figure that out how I can do that. But yeah, basically we then sample our noise function, which we can do like that. But I think we actually just want the value. We don't really care. But it's fine, we can do both. Basically it would be that. Move to sampler function. And then basically if our position dot our position how do I do that? Oh no, wait. Yeah, we sample on the position, that's it. Yes, so we sample on that position. That's what I wanted to do. So we sample on that. Don't care about that gradient, we don't need that. And then we just do float distance to surface. Is basically that. And then if our extends times extends is greater than our distance to surface, times distance to surface. Do we need that? Actually no, we don't need that, sorry. We're not doing a vector length anyways. So if our extends is equal to that, well actually not that, it's fine. Do we? Yeah, let's return. Then we return here. So basically if we are not within the surface range, we don't do anything. Otherwise we subdivide. Well, actually 7. Valid mask. I don't actually know which ones are valid. The valid was... What was that again? Sparse oak tree. Is that the paper? Neither bit is set, the slot is not intersected by a servant and is therefore empty. The bit invalid mask is set. Ah, okay. Wait, what? I did a leaf mask and not a child mask, okay. That is it, okay. So we probably should card a leaf mask. So in that case, we do this, right? We subdivide into 7 pieces. But the leaf mask is a little bit up for debate. I mean, I guess we could verify that already. Sample children. Or actually we could probably just get back to our parent. No, right? We don't really know where the parent is. We only know where our children are. Unfortunate. But that would basically be here an atomic add. On the node count here. By 8. And that would be 7 if we are the last one, right? Now we need to dispatch the child creation here. We probably want to sample our children. I mean, we do a little bit of double checking them, but let's actually create that function to make it a little bit easier. Float get sample value. Return distance to surface here. And that is basically float get, well, yeah, distance to surface. Is this at our node center position? Oh yeah, let's actually do that. Yeah, and then if yeah, because this is the word chunk tree, right? We're just subdividing if the center hits and is close to the surface. Actually, maybe we don't do that then. Do we instantly subdivide all the way? Maybe not actually. Maybe we actually check each child. So float child extends. Is that correct? So if we have 16 and we shift that by 1, oh god, should be it, right? Oops, wrong direction. Yeah. But that's the wrong direction. We want it like that. So if well, and then yeah, distance to surface. Isn't that just plus and then we move in that direction? But I mean, I guess we can just do node center position. Minus child extends. would be like 1. Well, we need half size of that. And then basically, if our distance to surface is greater wait, is that correct? Oh, I extend. Oh, yeah. If basically our child extends. Yeah, it is actually this child half extends is greater than our distance to surface. Then we are within the bounds. And we would basically or equals our position in. And then let's do that in a loop. That one we need to adjust, of course. But yeah, that would be the idea. It's a bit much here, one at a time, but Oak3 node. And that is valid mask. Well, the valid mask we have always, right? Because we always subdivide by 1, like by all of them, right? Or not? No, yeah, we always subdivide, right? Oh, actually, maybe not. So that's the surface. Ah, but in this case, I see in this world chunk tree, the leaf and valid mask are kinda useless. So maybe I get rid of that actually. Because does it add anything to know that it's a leaf? Not sure. And I mean, I can't really know if I have children or not here. Is there a way that I can get back to my route? Just learned what is a mesh shader the other day. Yeah, but mesh shaders are unfortunately a little bit weird, to be honest. I mean, I would want to use them, but the weird part about mesh shaders, at least in Vulkan, if I read that correctly, is that they are only 256. They only support 256 vertices. So you need to dispatch a bunch of them. Which eventually we might do, but yeah, I'm not sure if it's worth it. So does the valid mask help, or does the child mask, or the leaf mask help us in any way here? Because in here, like that would be similar to the volume chunk tree, which we built later, but the word tree is basically just where we have chunks. I mean, okay, no, it actually makes sense. How do you build the vertices? Copy GPU, CPU, GPU. They are built in Compute Shader. It's all on the GPU. There is nothing on the CPU currently for those meshes, for the terrain. We need to eventually get some data back for physics, but for now everything is on the GPU. Alright, so that would help, but how would I sync that? I mean, I guess what we could do is have the queue here as a struct, maybe. Basically like 2 UNs, something like that. And the first 32 bits are the parent and the other one are the child index. That way we could write into the parent. But is that really worth it? Probably not. Maybe I just do a step afterwards that goes over the tree and flags leaves. That's interesting actually, how I would do that in the other one as well. So you can get vertices data from compute shader too? Yes, you can. You just put them as a, you just create your buffer. Where is it? Volume terrain system. You just create your buffer as a storage and vertex buffer flags, right? So in Vulkan that would be wherever we have it. Yeah, the uniform, like VK buffer usage storage and VK buffer usage vertex, right? You put both of them on your buffer during creation, and then you can use your buffer in compute shaders and in vertex buffers. The only thing you need to ensure is that you put a barrier right after like your compute shader. So we do that in terrain panel, right? So basically on the mesh, which is here. Did I do a wrong one? Yeah, I did. So that should be vertex read on the mesh vertices, right? So we do our compute shader, we say we want to write to the mesh vertices in the compute shader, we dispatch our compute shader, and then we put the barrier again that the next pass will read from it. Mesh shaders are faster, yes. And the benefit of mesh shaders as well is in the fact that they are so small, because what you can do with mesh shaders really nicely is because they are only 256 vertices each at maximum, you have like very small chunks. Mesh buffers. There is a nice, hopefully the image is here. I mean, that would work, but yeah, exactly that bunny I was looking for. This is in the official one. So you basically see all the areas from the mesh buffer draw, or from the mesh shader draw cores in different colors. And you can see that there is a bunch of them just for this bunny. But what that enables you to do is you can cull each one individually, which basically makes it possible that usually you would render the whole, or like here for the dragon, right? You would render the whole dragon always because you have one mesh. And if there is a sphere in front of the dragon, you would still have to draw the whole dragon because that's what you cull against. But with mesh shaders, you can cull individual parts. So if there is a big sphere in front here, you would not draw any of those areas. But you wouldn't break your thing because you still draw like the stuff that you see from the dragon, but you don't draw anything you don't need to. So it improves a little bit the overdraw and stuff like that. And culling culling and stuff like that. Occlusion culling gets better with the mesh buffers. Mesh shaders. I hope that made sense. It was a little bit, again, talking is hard. I wonder if there is a way to do what I want to do. Let me think again. I mean, we can always do a step afterwards, but I mean, I guess I could verify if we... Yeah, exactly. So mesh shaders are the meshlets, basically. It's just a different term for it, but it's basically the same thing. Maybe I don't need to check that. Maybe I don't need to check my own center. Because let's assume that my parent already checked that, right? So basically I am this big. I will check the positions of my children. And then if I subdivide, I basically subdivide like that. And I'm only a leaf. The leaf mask is still a problem, right? In that case. Or is it? Well, actually, in this case, one of them will probably subdivide again, right? So we probably are not a leaf in this case. So we definitely are valid in all of them, right? Or maybe not. So let's do that. The valid mask is that. Oh, god damn it, it's so complicated. I am created by my parent. My parent and then I check my child, and my child has a surface in it. So I am definitely doing that. So that is that we are doing a surface thing, yeah. And then we are always, in this case, a leaf only if we are not the last level, right? Otherwise, yeah, I'm not sure if that actually really helps too much. Ah, those two flags are a little bit mind-blowing for me currently. I'm not sure when I should set them in this case. Yeah, actually, this is, I think, only true if we are actually not subdividing anymore. Then we are a leaf. Then we have like a state where we are a leaf, but it's... No, that doesn't make a lot of sense. Leaf voxels do not require a descriptor of their own as they are described by their parents. The valid mask says if we have data or not. So I guess we would only trigger that in this case if we are... So in, I think in the word octree it is kinda useless. So that is only if... I think that would be a U and depth. Or like... Yeah, U and... Let's do depth, I don't know. And let's say if depth is 4. Well, or 3 because we begin. Then we do that. Now we are a leaf. I mean, actually, otherwise we just always say as well that we are a leaf. I think it doesn't harm to do that. Although, probably it doesn't matter, right? We definitely have the children here that we do. That one we leave empty for now. I need more info in the create stuff, because I need to know where to put the node. Oh, that's interesting. Okay. That is the pointer to the children. So probably the Morton stuff actually doesn't help me too much. Maybe we just pass that around. Actually, we could probably pass an offset. That could be the offset into the buffer, right? So we still need the position somehow. But yeah, basically that would be then out. Create request. if we split, we always split by 8, right? Basically, this should actually can do actually that. So if R is not 0, then we split. Now we basically do that. Definitely do that. Then we do this and we do an add create request queue. Add that one. Plus 0 is that one. Think 5, 6, 7, right? Is that correct? So that cues the creation of our 8 children. Then we still need the dispatch, but... Oh wait, we can... Oh, okay. That's interesting. The dispatch will be a kinda... That one will be fun, not. Huh, I will be right back. I will get something to drink and quick toilet break. All right, let's keep going a little bit. Hello, welcome to the stream. All right, so let's keep going. Yes, I am, and I actually am in the games industry since 2011 professionally, and then this is my side project. Sure. What's your question? Actually, I should have YouTube chat open as well, but I don't. I'm not that anyone watches me on YouTube, but let's open it regardless. Not sure. How do you start a game project without reference? I mean, that's a bit broad, right? What do you mean with like without reference? Reference of what? Games like what? Watch Dogs and GTA. I mean, the thing is, usually someone comes up with a game idea or game design, right? In like bigger companies, there's like dedicated roles for that, which are like usually like game designers, or like game directors. I mean, sometimes like people push as well, like for ideas, right? Ah, okay, reference is a picture. Well, usually like nowadays, most of the ideas are like variations or like, yeah, variations of games that already exist, right? There's not really that much new stuff coming. I mean, there are some indie games that are new ideas. I don't know, that's like a too broad question, right? It's like not a straight, easy answer how to do it. Hey, Mickey Maven on YouTube. Now you're in two chats or what? It's really hard to answer like such a broad question. It's like basically you're asking how to get an idea. It's like you either play games and then you think, hey, that is a cool idea, and you maybe iterate on it and come up with like a game that's like similar but like a new twist to it. There's like there is no set like guideline how to come up with an idea or how to start it. But then once you have your idea, you should like evaluate what you need for the project, right? Like for GTA, for example, or Watch Dogs, you want like big words, so then you probably need an engine that supports that, like for example Unreal, which usually supports like big words, but I mean Unity as well, but nowadays. Yeah, that's what I'm asking, how you start building the environment after opening a new open template. I mean, in Unreal and Unity, you have like terrain editors, right? That would be the first thing that you would probably do if your game is an open world game or an outside game like GTA, for example. You usually create like the base terrain on a height map. For that, you already need to kind of know what it should look like, right? Or like in what area it is for a GTA most of the time, and Watch Dogs as well. It's like a real world reference, right? They always are in a real world city most of the time. So it's like makes it a little bit easier in terms of like world building, because they can structure their terrain based on the real world. But yeah, it's like it's really difficult to answer that. There's like 100 avenues that you can go for that, and I would recommend a smaller game to start with than comparing something to GTA or Watch Dogs, because those are games done by 200-300 people. Nice, at least my YouTube overlay works, so I see the chat in YouTube as well on the stream. That's good. Thank you, Mickey Maven, for testing that, I guess. Yeah, I'm sorry. It's a little bit too open, the question, right? It's basically how do you... The question is on a similar level of like, how do you cook something? And like, there's 200 ways to do that, unfortunately. It's really not that simple. There's like not a guideline that you can follow for that. Yeah, I mean, what Rainbow Jimo is saying. It's like, those huge projects, they are always, as I said, done by hundreds of people. At Avatar, when I worked there, it was like a team of like 200-300 people working on the game. And yet they make crap. God damn it, savage. Alright, so where was I? Oh yeah, this part. Do I have everything in place now? I mean, not that it runs, but do I have everything logically in place? I think I really need this to be U in 64th, so that I split it in half, as I said. Where this one is basically the first 32 bits. And then Morton index, which is basically the position of the node, which we shift by 8. No, 32. Right? I think so. Last good game released was Minecraft. Not sure if I agree with that, but there are other good games as well. Bala what? Balatro. It's a deck, well, deck builder, kinda, right? Ish. Morton index node offset. So we do all of those, and then we do the Morton index, right? Which as well, I think it's fine to do like that, basically, where we push one lever down. But do I do it like that? I'm not sure anymore. I would need to read up on the Morton index stuff again. Is it like that? Well, and then of course we need to shift those by 32 to the right. Something along those lines. But I would need to test that. Rainbow Six has free access? What do you mean? It's free to play or what? Oh, yeah. Okay. Well, I mean, I know they talked about it when I was still working there, but didn't think they would come through with that. Okay. Well. I think I will call it a day today. There was like enough brain juices for today for this, and I need to still do some more reading on the Morton stuff, Morton code again, because I wrote that as well 2 years ago, so I have no idea how that works again. How to push those correctly. I think that's fine, but I'm not entirely sure. I mean, like this is just shifting it into the 64-bit, which is not important. But I think that's it, but I'm not sure. But yeah, the idea would be, as I said, basically this, and then that we then we have the word octree. The volume chunk octree is a little, I mean, it's not simpler by any means, but once we have this figured out, the volume chunk octree is basically a copy, just that the split heuristic is different. So once we have the word chunk tree, it will go a lot easier for the other one as well. But there's a couple of things that I need to figure out. How do I do the dispatch without the second step? I think it should work. Not an atomic add. But is there an atomic set or something like that? What do we have here? Wait, what is this? What is that? Well, whatever. Atomic counter. Ah, we can do an atomic max. That would be it. I think there is an atomic max, right? Yeah. So basically we would do atomic max here on the dispatch in X direction. It's basically this, where the count plus 8 divided by thread local size. By that, it should be that. Hey, thank you for the follow. Snarlip. Thank you. But we will call it a day. No, but that should work with the dispatch. We might need to seal it. Although it should be... yeah, we need to seal it definitely, right? Because we always want to get at least one dispatch. Well, do we? Well, we want to get one dispatch if we have something. If it's 0, we don't need to do anything. But then again, we don't enter here if we're 0, so all good. We do that actually, GR. So if well, we have that somewhere here already, I think. Or here? Oh yeah. So we basically initialize it to 0 at start. And then we do that. Alright. I will do some reading and then we will be back tomorrow and we will hopefully finish that and we can see the volumetric, well, the octaword tree in RenderDoc, because we will not be able to see something in the word actually, as long as we don't have the chunks. But hopefully, like as I said, once we have that octree done, the other one is pretty much the same, except that this is different. The heuristic to split basically is different. but... And the heuristic to split I already have here in C++. Yes, I am. I am indeed doing my own engine. I'm not sure if I still have it. Let me see. Maybe I can show you. Might not work because I don't know when I built it the last time. Okay. Well, it seems to work. Yeah. So we have this, right? And we have here our beautiful terrain plane currently, which is a noise generated volumetric terrain. So if we make it smaller again. Oh shoot. I think I crashed it. Yeah. It's not flawless. Especially the terrain currently has some problems sometimes. But yeah, basically if we do here 64, then we can paint as well here. So it's all volumetric voxel terrain, similar to like you could imagine it like Minecraft. And then we can dig out holes as well, so we go here into the terrain, right? And yeah, there's we have PBR and lighting and all of that. And we have our beautiful render and shader graphs basically. So the render pipeline in this engine is fully data driven. So if we open it, I think we are using this one. You can see that we have our render passes here. And that's basically what the GPU is doing, right? So we have our static mesh, our editor grid, our sky, which we saw before. So this sky here, right? That's like this part here. That is our lighting that goes in. That's our depth prepass. And then we have here the composite and the tone mapping. And finally the ImGUI, which is our UI. And then we have as well the shader graph, which for example, oof, okay, that's interesting. So for the shader graph, it should work, but let's see. Which one is it? Is it that one? Okay, maybe not. And I don't know why it was like that. That's a UI issue that we had like two. So let's open that again. Oh, God damn it, where is it? Oh, here. Maybe it's this one? Oh, it has to be that one actually. Oh yeah, okay. It was just that the UI was wrong. And then you have like in Unreal, right? You have like a shader graph where you can build shaders. So here we sample textures and then we get a material out, and that's basically what we use in the scene to actually render this terrain, right? So it uses a material, and that's this one. And that's a basic tree-planar shader. Yeah. Alright, but I will call it a day for today. And we will be back tomorrow. And we will finish our terrain stuff. I mean, not finish, but move on with it. And hopefully get our volume, like world size volume 3 up and running. And then we do the chunks, and then I think we are close to having everything I wanted. So yeah, have a great rest of your Saturday. And I hope to see some of you tomorrow. We will stream tomorrow again, probably at 3 p.m. I might be a little bit late because I have some lunch plans. So maybe not 2:30, maybe 3, but I will try to be on time for 2:30. Have a great day. See you tomorrow. Bye bye.